Welcome! In this video, we are diving into Cesium Stories, a powerful tool for creating interactive 3D geovisualizations. This is part of our series on mapping in 3D, and today we'll focus on how Cesium helps you bring geospatial data to life through storytelling. We'll start with an introduction to the platform, covering its key features and why it's a great tool for 3D visualization. Then we'll move into a hands-on demo where you can follow along as we build an interactive 3D story step by step using Cesium Stories. By the end of this session, you'll be able to create and share your own dynamic 3D presentations with ease. Let's go ahead and get started. Cesium is a cloud-based platform that makes it easy to upload, process, and visualize massive 3D geospatial datasets like buildings and terrain right in your web browser. It converts raw 3D data into an efficient format called 3D tiles, allowing you to stream and interact with large-scale maps without needing a high-powered computer. Whether you're studying urban planning, environmental science, or game design, Cesium helps you bring geospatial data to life in an interactive and accessible way. Cesium provides many high-quality global 3D datasets, including Cesium World Terrain, which integrates real-world elevation data for detailed landscapes, and Bing Maps imagery for clear satellite and aerial views. A key feature is Cesium OSM Buildings, a global 3D city model built from OpenStreetMap data. This means any 3D attributes added to OSM, such as building heights or roof details, are reflected in Cesium's data layers, keeping it up-to-date and community-driven. You can also integrate your own 3D data, including drone imagery, CAD models, or LiDAR, to create even more detailed visualizations. Cesium Stories is a powerful tool that lets you create interactive 3D presentations without needing to write any code. It's a great way to communicate complex geospatial information in a clear and engaging way. With Cesium Stories, you can add labels, annotations, and pop-up descriptions to highlight key locations or data points. You can also measure distances and areas directly on your 3D map, making it useful for everything from city planning to environmental analysis. Once your story is ready, sharing is simple. You can generate a link to send to others or even embed it on a website so viewers can interact with your 3D visualization in real time. Whether you're showcasing research, telling a data-driven story, or presenting geographic trends, Cesium Stories makes it easy to bring your maps to life. Cesium integrates with OpenStreetMap to bring cities to life in interactive 3D. As a community-driven mapping platform, OSM is continuously updated by contributors worldwide who add details like building footprints, heights, and roof types. Cesium processes this data and converts it into Cesium OSM Buildings, a lightweight, scalable 3D city model that can be streamed seamlessly in any web application. Because OSM is constantly evolving, Cesium OSM Buildings stays dynamic and up-to-date, reflecting real-world changes in urban environments. One of Cesium biggest advantages is its ability to automatically convert large 3D datasets into 3D tiles, a format optimized for fast, seamless streaming. Whether you're working with models, terrain, or point clouds, Cesium processes and tiles your data so it runs smoothly in a web browser. It also securely hosts your data in the cloud, eliminating the need for expensive hardware or manual optimization. This ensures fast loading, easy sharing, and seamless integration into other interactive applications. And that's where Cesium really shines. It makes streaming your 3D data effortless. Whether you're using Cesium.js, game engines, or GIS software, Cesium dashboard gives you full control over managing assets, monitoring performance, and setting permissions. This smooth integration makes working with 3D geospatial data easier than ever. We've only scratched the surface of what Cesium can do. Beyond this overview, you can dive into real-time data visualization, interactive simulations, and even build custom applications. For now, let's jump into a hands-on demo and create our own Cesium story. Now that we've covered Cesium Ion and its capabilities, let's dive into the hands-on portion of this training where we will create an interactive 3D story using Cesium Stories. In this demo, we'll build an interactive 3D story to visualize urban growth and green space distribution in New York City using real-world datasets. We'll work with OSM 3D buildings, New York City green space data, and high-resolution urban models while exploring key geospatial concepts. You'll learn how to create scenes, integrate datasets, apply custom styles, and share your final story online. Now let's dive in and start building. I'll start by opening a web browser and navigating to cesium.com. In the top right corner of the screen, you'll see the Sign Up or Sign In button. If you don't already have an account, click Sign Up and follow the on-screen instructions to create and verify your account. Once you're signed up and logged in, you'll be taken to the Cesium Ion dashboard. This is where we will manage datasets, upload files, and access Cesium Stories. Before we move forward, let's take a moment to explore the key sections of the dashboard. On the top of my screen, there's a navigation menu with 3 key sections we will be using today. First, there's the My Assets tab. This is where I can view, manage, and upload datasets. Any previously uploaded datasets, like these GeoJSON files, will appear here. You can upload your own data by clicking the Add Data button. Next, we have the Asset Depot. The Asset Depot is Cesium's built-in library of ready-to-use geospatial datasets. If I hover over one of these datasets, I can see a brief description of what it contains. If I click on one, I can see detailed metadata on the right-hand side of my screen. Now, for our demo, we need to add a few important datasets. Let's start by searching for New York City 3D buildings in the search bar. Once I locate it, I'll click the plus sign to add it to my asset library. Next, make sure that you have Bing Maps Aerial, Cesium OSM buildings, and Google Photorealistic 3D tiles already added. You can check if they're added by looking for the minus sign in the Asset Depot tab or looking in the My Assets tab. Now that I've added all my necessary data layers, I'm ready to start creating my story. I'll navigate to the left-hand menu and click on Stories, which takes me to a section where I can create and manage my 3D presentations. On the left side of the screen, I see a New Story button. I'll go ahead and click that now to open up the Cesium Stories editor. Looking at the editor, I notice 3 main sections. On the left, there's the Slides panel, where all of my story scenes will be listed. This is also where I can add new slides. Next to it, there's a panel for adding text information and managing assets. In the center, there's the main map view, where I can visualize and interact with my data. Additionally, on the far right, I see a compass and zoom controls, which allow me to orient and navigate the map. And finally, at the top, the menu bar provides options to capture views, present, and share the story. To begin, let's navigate to New York City. I'll go to the search bar in the top right corner and type Central Park, New York, and I will select the first result from the drop-down menu. Immediately, my camera zooms into an aerial view of the park, giving us a great view of how this green space is situated within the city. To refine this perspective, I'll adjust the camera by clicking and dragging the compass on the right-hand side of my screen to rotate the view, and I'll use my mouse pad to zoom in and out. Once I have a clear and engaging view of the city and the park, I will save this scene on the slide by clicking the Capture View button. This ensures that I can return to this exact camera position later. Before we explore our datasets, let's provide an introduction to our story. This first slide will serve as an overview, giving viewers the necessary background information before they dive into the details. I will first ensure that my slide is selected on the left panel. At the top of the screen, I will set the title to Exploring New York City's Urban Growth and Green Spaces. Now I want to add text to the info box, so I'm going to click inside and paste a description. In the top left corner, we can also enter the name of the story project. So let's go ahead and change the title of the story to New York City's Urban Growth and Green Space Distribution. Now, with the title and description set, I'll click Present in the top right corner to see how it all looks. The info box appears in my slide, ensuring that viewers receive the necessary background information. The Cesium OSM buildings layer is built entirely from OpenStreetMap data, which means every building you see here has been contributed by mappers from around the world. As I zoom in and click on different buildings, we can see detailed metadata about each one. These attributes come directly from OSM contributions and include information such as building color, material, roof shape, and height. This level of detail in the metadata allows Cesium to render accurate and data-rich 3D city models, making it valuable for visualization and analysis. If you're interested in learning how to map 3D building attributes in OSM, be sure to check out the other videos in this series. Now that we understand how Cesium integrates OSM data, let's move on to the next step. Now let's add a 2D dataset that represents New York City's parks. To begin, I'll create a new slide by clicking the New Slide button in the left panel. Next, I need to download the dataset. I'll open up a new browser tab and navigate to Overpass Turbo, a tool for extracting OpenStreetMap data. Here, I'll enter a query to find all parks in New York City. If you're following along, you can pause and copy the query into your own browser. Once the query runs, I'll click the Export button at the top and download the dataset in GeoJSON format. You can choose either GeoJSON or KML, as these are the two formats compatible with Cesium. Now that I have my dataset downloaded, I will return to the Cesium Stories project. To upload it, I'll go to the My Assets tab on my dashboard and click Add Data in the top left. Here, I will add my downloaded GeoJSON file. Then I'll click the Upload button. A loading bar appears on my screen indicating that the file is being processed. Once the upload is complete, I can see the dataset in my Assets panel. Before adding it to the slide, I can update the title, add a description, and include source attribution to give proper credit to the data providers. Next, we will reopen our story and navigate to Slide 2. In the panel, scroll down to the Assets box and click the plus sign to add a new asset. In the pop-up box, you will see all of the datasets and imagery layers you have in your asset library. Locate and select your recently uploaded parks layer and click the Add button to add it to our current slide. Immediately, the green spaces appear as overlays on the 3D map. To improve visibility, I'll zoom in and out using my mouse wheel and adjust the camera angle by clicking and dragging. This makes it easier to see where parks are distributed across the city. Now that my scene is set, I'll go to the top menu and click Capture View to save this perspective. Now that we've added our dataset for New York City parks, let's provide some context for viewers by adding an info box. First, I'll make sure Slide 2 is selected in the left panel before adding a new title for this slide in the title box. This will be the title that viewers see when they land on this slide. Next, I want to add some explanatory text. Below the title field, there's an input area for the info box. I'll click inside this box and paste a description about the importance of green spaces in urban environments. Now that I've entered my text, let's see how it looks in presentation mode. I'll go up to the top right corner and click Present, launching the story's viewer in a new window. I can see my title and info box displayed clearly alongside the New York City Parks dataset. Everything looks good, so I am going to go ahead and exit Present mode and return to the editor. With our info box added, our slide is now more informative and engaging. Now, let's explore how New York City's buildings have evolved over time by applying color styling based on their year of construction. First, I'll create a new slide by clicking the button in the left panel. Since we don't need the New York City Parks layer for this step, I'll uncheck it to keep the view focused on buildings. Now, I need to add a dataset that contains building construction years. I'll go to the Assets panel on the left, click the plus sign to add an asset, and select New York City 3D buildings from the asset library, which we added at the start of the video. Once selected, I'll click Add to load it into the map view. To prevent duplicate imagery, I'll now turn off the Cesium OSM buildings layer so that only the New York City 3D buildings dataset is visible. At this stage, the buildings appear in 3D, but they do not yet have any color styling applied. To style the buildings by year built, I need to open the styling editor for this dataset. In the Assets panel, next to the dataset name, there's an icon of shapes. I'll click on it to open the styling options. Next, I'll click New Style button at the top. Here, I have the option to set the property and style type. To determine which attributes are available, I'll click on a building in the map viewer and select View Info. In the pop-up window, I can see several attributes, including year, which indicates when the building was constructed. Back in the styling editor, I'll select year from the property selection dropdown. For style type, I'll choose graduated, which allows me to apply a color gradient so that older buildings appear in a darker color and newer buildings in a lighter color. After clicking next, I can customize the legend title and symbology colors. First, I'll update the legend title to year built. Now I'll define the color gradient. Some buildings in the dataset lack construction year data, which is recorded as 0 in the metadata table. To visually distinguish these, I'll set the lowest value 1 to light gray, ensuring that any buildings with a construction year of 0 are displayed in this neutral color to indicate missing information. Next, I'll mark the highest value to be the year 2025. From there, I'll click the plus button below the gradient line to create new classes that follow 100-year-long increments from 1700 to 2000. Next, I'll apply a light blue to dark blue gradient, where older buildings appear in darker shades and newer buildings appear lighter. Finally, I'll turn on the Classify switch towards the bottom of my screen. This will update the legend with our new classes. If you're following along, pause here to finish symbolizing your legend until it matches the example shown on screen. Once I'm happy with my settings, I will click OK and then click OK again to close the styling page. Now my map clearly visualizes which areas of the city have historically significant buildings and which areas have seen more recent development. Let's start by taking a step back and looking at New York City as a whole. I'll zoom out to get a broad view of the skyline, showcasing the city's diverse architecture, from its historic neighborhoods to modern skyscrapers. New York City has undergone continuous development for many centuries, and this visualization helps us see how the city has grown over time. Next, I'm adding a title and description to this slide's info box, offering viewers additional information on what they are seeing in this slide. Finally, I'm going to arrange the map view to offer the best visualization of New York City's skyline, clicking Capture View when I'm happy. Now that we've seen the bigger picture, let's zoom in on a specific neighborhood that embodies New York's rich architectural history, Gramercy Park. We'll start by creating a new slide and searching for Gramercy Park in the search bar on the top right corner of your screen. Gramercy Park is one of New York's oldest residential neighborhoods, known for its 19th century brownstones and historic landmarks. Many of the buildings in this area date back to the 1800s, making it an ideal location to analyze historic urban development patterns. Next, let's add an info box to convey some of this historical information about this neighborhood to the viewers. I'll name this slide Gramercy Park, a historic neighborhood, and copy and paste the following text into the description box. Once I'm happy with how the map viewer looks, I'll go ahead and click Capture View to save this perspective on this slide. By exploring this area, we can see how different time periods of construction have shaped New York City's urban landscape, blending past and present into a single evolving cityscape. Let's take a moment to walk through our final story, highlighting the narrative we've built using 3D geospatial data. We began by examining New York City's parks and green spaces, using data from OpenStreetMap. This dataset gave us a detailed look at parks, helping us to see how they are distributed across the city. Understanding where parks are located is crucial for urban planning, sustainability, environmental studies, and more. Next, we shifted our focus to New York City's built environment. We explored the skyline using New York City's 3D buildings, which provided a detailed 3D representation of the city's architecture. This allowed us to analyze how the city has expanded over time, identifying historic districts with older buildings and modern developments with newer construction. Finally, we zoomed into Gramercy Park, one of New York City's oldest residential neighborhoods, to take a closer look at historical urban development patterns. Through color-coded visualization, we identified how building ages shape this unique area. Now, let's make our story accessible to others. I'll go to the top right corner of the Cesium Stories editor and click Share. This will open the sharing menu, where I can then toggle the Enable Sharing button generating a public link that anyone can use to view the story. If I want to embed this story into a website or blog, I can click Embed, and Cesium will provide an HTML code snippet that I can easily insert into any web page. If at any point I want to make the story private, I can return to the Share menu and disable sharing, restricting access to just me. This entire 3D visualization is built on a foundation of OpenStreetMap data. The Cesium OSM Buildings layer is a living dataset, continuously updated by mappers around the world. The more detailed building attributes, such as roof types, materials, and heights, that are added to OSM, the better Cesium's 3D tiles become. What makes this experience so powerful is that we're not just looking at a flat map, we are interacting with a dynamic 3D model of the city. Cesium Stories allows us to create immersive, data-driven narratives, and this is just the beginning. There's so much more to uncover with Cesium Stories. Whether you want to visualize transportation networks, infrastructure projects, climate impact, or historical changes, Cesium provides the tools to bring your data to life. That wraps up this session on creating 3D geovisualizations with Cesium Stories. A big thank you to Cesium for their support in making this video possible. If you found this tutorial helpful, be sure to check out the other videos in our 3D mapping playlist. Don't forget to like this video and subscribe for more content. Thanks for watching and happy mapping!